Our next video is on hyperbolas, and it's going to be very similar to what we did with an ellipse. It has a center, as you can see here. It has a vertex. It's going to look like two parabolas, and it's got a focus, just like an ellipse. And notice the focus is always being hugged by the parabola looking things on both sides. It has asymptotes that it approaches on both sides that are the diagonals. And it also can open horizontally like this one, or vertically like the one below. Notice that our hyperbola comes from our plane, cutting our two cones vertically up and down. I get these two parabola looking pieces, two-dimensional. So we're just going to go into the definition, and then we'll go into graphic. The first is the definition is the set of all points in a plane such that the differences, remember an ellipse was the sum, the differences of the distances from the foci is constant. If we go back up to the picture, remember there's these focus, and if I took a point and I did from here and then to the other one, so I'd have this D1, D2, and I subtracted them, those distances would be constant no matter which point I picked on the hyperbola, either hyperbola. We have two different, just like a ellipse, we have a horizontal and vertically opening hyperbola. The horizontal looks like an ellipse. However, there's a minus sign in between the two terms, and it's equal to 1. The vertical, notice my y value is going to come first. So that's how you're going to tell whether it opens left or right or up and down, is going to be which variable comes first. Whereas the ellipse, which was the bigger denominator, was the distance that you traveled. Okay, we have two axes. We have the transverse, and we also have the conjugate. The transverse axis is from vertex to vertex. And the conjugate, I'm just going to say the other distance. Just depends how you're opened, and you'll see what I mean as we graph these. Okay. The vertices, which will be right here, kind of be like the vertex of the parabola, is 2a. Or is it, I guess that would be the, let me change that. That'd be the transverse axis. That's what would be 2b would be the conjugate. And the vertices are a distance from the center. since on this one our A is always going to be associated with how it's opening. So notice that the A squared is going to be the distance from the center in the X direction, and it's going to go horizontally, open horizontally because the X comes first. On the vertical, notice over here it's under the Y, and so it would be the distance I travel vertically. So it depends what variable you're underneath. And then to find the foci distance, you are going to sum them together. Your A squared should be squared, which is different from the ellipse where we subtracted them. And we're not going to do the semi-latus recti. Okay, so we're going to get on graphing, and this will all make a little bit more sense. Okay, the first thing I want to notice is that these are definitely opening horizontally. So I know I have a center at 0, 0, and I know my X is going to come first. It's a subtraction sign because it's a hyperbola. And I know I traveled 2 units to the left and 2 units to the right. So I know there's a 4 underneath my X. Now it's a little trickier getting the other direction to go up and down. What you have to do is create a box from the vertices, and you're just going to extend up and down until you reach the asymptotes. And then you're going to create a box or a rectangle, sometimes it's a square, and then that will reveal the distance in the other direction, which would be 3 units up, 3 units down, squared would be 9. So very similar to a ellipse when it comes to getting the directions and locating them underneath the denominator. Next one is a center 0, 0 again, but this time it's opening vertically. So my y squared is going to come first. It's going to equal 1. And so since my transverse axis connects vertex to vertex of my parabolas, I notice that that's going to be 1, 2, 3 units long. So it's 9 vertically, and then I've got to create these boxes by going all the way out from the vertices to the asymptotes. And then connect the other way. And then that will reveal the other direction. 1, 2, 3, 4. And I just checked the other side 1, 2, 3, 4 to make sure that I did my boxes correctly. Sometimes it can be off a little bit. Notice that the transverse axis is the vertex to vertex distance, which is 6, which is shorter than the conjugate axis, which is 8 units. So it's not dependent on size like the ellipse was. We had the major and minor axis. On a hyperbola, we don't have that. Okay, so I'm going to let you work the other two, and then we'll look about defining this one. I'm going to look at, let's look at a number 5. So I have a center 0, 0. Remember, we're not going to do the semi-latus recti. And then I'm going to do the square root distance, 2 and 4. I'm just going to go ahead and I could find the transverse axis. Remember, that's the one that is directly related to the opening from vertex to vertex. Since the X comes first, it's going to be horizontal. So it's going to be this very first one, which will be a length of 4. And the conjugate is the other direction, which is going to be 4 and 4, which would be an 8. I might as well get my foci length. It's found by summing the two together. 2 denominators, which I get the square root of 20, which is somewhere between the square root of 16 and the square root of 25, which is about halfway, so approximately 0.5. And now I'm ready to travel my lengths. So I'm going to go 2 units in the X direction. And then I'm going to go 4 units up and down. 1, 2, 3, 4. 1, 2, 3, 4. So exactly the same. If this was an ellipse, I would just go ahead and make a oval, but it's not, so I'm going to create a box. And then what am I going to do is I'm going to put my asymptotes, and those go through the corners of my boxes. Just do the best you can. And those create the asymptotes of which my parabola looking things approach on the left and right side. Okay, so I know it opens left to right because my x variable came first, and now I'm ready to put my foci in, which are hugged by those parabola, which they're 4.5 from the center. 1, 2, 3, 4.5. And then 1, 2, 3, 4.5. Let's do one more that has a vertical. So let's look at number 7 right below. And careful on these when I do the center, right? Because my x is coming second, it's -2, and my y is coming first, which is -1. So it can be oriented a little bit different than all the other conics where you have to pick the x comes second in the equation. And then I'm going to do my square root distances, which is 4 and 3. My transverse distance is how it opens. It's opening vertically, and I'm traveling up and down 4, so a total of 8 units. And my conjugate's just the other direction, which would be 3 and 3, which is 6. And then my foci distance is 16 plus 9, which is 25. 5. That's nice. And now I'm going to graph my center, -2, -1. And I'm going to travel up 4 units and down 2, 3, 4. And then I'm going to travel left and right 3. This time I'm going to create a box. Put my asymptotes through. Here's my vertices because it opens in the y direction because the y comes first, so I know parabola things. And they're usually a little bit more flattened out than a regular parabola. And then my foci was 5 units, so 1, 2, 3, 4, 5. Focus hugged by my parabolas, 1, 2, 3, 4, 5. And then I could also get, I forgot I didn't put the asymptotes slope on there, and they're going to be plus or minus. You're just going to do rise over run from the center. So I rose up 1, 2, 3, 4, and then 1, 2, 3, which matches the distance, right? So plus and minus thirds. Could do the same thing up here, and I went up 1, 2, 3, 4, and then over 2. So my asymptotes, its slope would be up 4 over 2 would be plus or minus 2. Okay. So again, pretty easy on graphing. Very similar to an ellipse. Just don't get them confused. That's why practice is very helpful. Okay, the next thing that I'm going to do, and I guess if you wanted to call these co-vertices, we could. The other ones that were not the vertices, these would be the vertices. I just noticed that. Vertices, oh, co-vertices, co-vertices. Vertices are the vertexes of the parabola and things. Okay, so just like before, we are going to complete the square. And so I'm going to look at completing the square on number 9. And so same thing as I would do with an ellipse. Collect my x's. This one's ready to complete the square. Half of 6 is 3 squared is 9. Now, no matter what on a hyperbola, you're always going to have to factor, because you have to factor out at least the negative sign with the one that's negative. But this one is going to be a -4. It's going to come out of the y. And then I'm going to pull a -4 out of this, which is a -4y. And half of 4 is 2 squared is 4. And I added 9 to this one. And what did I really add to this one? A -16. So I have to add a -16. And then I have an x plus 3 squared minus 4. And then I have a y minus 2 squared. And then I have over here 20 minus 16, which is 4. Divide everything by 4. Get it equal to 1. This is going to be one that opens left to right because my x comes first. You might say, well, what is it going to look like when the y comes first? And I'll show you. So I can tell you this one is obviously the x is coming first. This one, the x is coming first because it's positive, and then my y squared is negative. If you look at like number 11 and 12 below, we'll work one of those. We'll look at number 12. Notice that my y comes first because it's positive and my x is negative. So here I'm going to pull out my 8 with my y, but it's got to lead because it's the positive one. 8 times 4 is 32. But I also, on my x, have to pull out a -3. No matter what, you have to at least pull out the -1. If it was just a -x squared, I'd have to pull out a -1. Remember, it's got to be a positive 1x squared or a positive 1y squared. So I'm going to pull out a negative. -12 divided by -3 is a positive 4. Careful on your signs on those. And 4. So what did I really add? Half of 4 is 2, squared is 4, so I'm going to add 32. And then this one, half of 4 is 2, squared is 4, and that's a -12. And then I'm ready to split the square. And what do I get? This gets me 20 and plus 4. And now when I divide, it's nice. All of these 3 and 8 are both evenly divided by 24. So 5 minus 2 squared. 24 divided by 8 is 3. 24 divided by 3 is 8. Equals 1. Careful on this one. When it's written backwards and it opens vertically, your center is going to be -2. You got to go to that x on the second. So easy to pick, say +2, -2 is my center instead of -2, +2, because the orientation is off. Okay, and I'll let you finish up the rest of these for homework, and I'll see you on Thursday and Friday.